together. On the far right, for instance, are the inert gases. On the far left are the volatile metals. The periodic table is a triumph of classification, giving scientists a way of organizing their knowledge of the material world.
Classification is simply a way to think clearly. I mean, what you need when you have some ideas about how the world works is that gives you a kind of schema, and you chop the world up into categories. And that actually helps you to understand, to make sense of what's around you.
People have been trying to classify the material world since ancient times. The Greeks, for instance, thought there were just 4 worldly elements: air, earth, fire and water. But this idea was a philosophical one and had little practical value. And that's what medieval Islamic chemists really changed. They used experimental observations to classify the stuff the world is made of. At the forefront of this was a medieval Islamic doctor and chemist called Ibn Zakaria al-Razi, who was born here in the city of Ray, just outside the Iranian capital Tehran, in 865 AD. Al-Razi's classification was very different from the Greek one. He argued, for instance, that minerals, roughly stuff we dig out of the ground, should be classified into 6 groups, depending on their observed chemical properties. The same guiding principle that lies behind the modern periodic table.
Now, what I've done is I've brought materials from his classification scheme. And we have here what he called the spirits. We have the metallic bodies, we have the stones, then we have the attriments, the salts, and finally the boraxes.
Each of Al-Razi's groups had a profoundly different experimental behavior. For instance, spirits were flammable. The metals were shiny and malleable. Salts dissolved in water. Of course, these classifications are not the way we do it today. But the point is that for the first time, Al-Razi was grouping substances on the basis of experimental observations, not philosophical musings.
We've come over 1,000 years since the work of Al-Razi. What sort of debt does modern chemistry owe to him for his classification?
Well, I think with Razi we start to see the first classification which really leads on to further experiments, the first schema which allows people to start doing rational work. And so really he lies at the start of almost formal chemistry, which ultimately leads to our periodic table.
I believe that what we see in the work of the Islamic chemists and alchemists is the first tentative steps to a new science. Yes, by our standards, it contained a lot of magic and mumbo-jumbo, but it placed an emphasis on experimentation that was truly revolutionary.
But bigger and better was to come, because Islamic mathematics and the experimental techniques of Jabir ibn Hayyan and Al-Razi were about to be welded together in a completely innovative way that would revolutionize their work and create the modern scientific age.
Until the 9th or 10th centuries, ideas about science and how the natural world worked were dominated by the Greek philosopher Aristotle, and they were very different from ours today. He believed that mathematics was concerned only with an abstract world of perfect forms, of idealized shapes like circles, squares and triangles. It had no power to explain what we observe in the world around us, a world characterized by irregular, wonky shapes and constant change.
Physics is a Greek word meaning the science of change. And for the classical Greek tradition, there was a strong sense in which the science of change was in contradiction with mathematics. Mathematics dealt with perfect knowledge, with the unchanging world of mathematical forms. And it seemed, in principle, extremely unlikely that processes of coming into being and passing away, of growth and of decay, of qualitative change, could be captured with the beauties of geometry and mathematics.
The story of how humanity shook off this idea and began to see that mathematics is actually an incredibly powerful way of describing the world around us is long and complicated. But for me, Islamic scientists played a crucial role, and I believe one man really led this movement to turn mathematics from a language of abstract thought into a truly practical science. He was, like me, from Iraq, and his name was Ibn al-Haytham.
What al-Haytham and his contemporaries argued for was the possibility, in a way, of a single science, which would be both mathematical and philosophical, which would link together a physics, a science of change, with a mathematics, a science of quantity. And that seems to me to be radical and crucial for the construction of new forms of reliable knowledge.
Ibn al-Haytham was born in 965 AD in the southern Iraqi town of Basra, and other scholars regarded him as a prodigy.
He shot to scientific fame just after the turn of the first millennium and was an incredibly innovative and brilliant scholar. His reputation as an intellect spread throughout the empire. But it was this reputation that would almost cause him to lose everything when he took up the poisoned chalice of trying to tame one of the world's greatest rivers.
There's a wonderful, if suspiciously apocryphal story about how Ibn al-Haytham's career as a scientist was transformed. It concerns the Nile and how, just after the turn of the millennium, Ibn al-Haytham was asked by the ruler of Egypt to find a way of controlling it. Could he prevent its unpredictable and potentially devastating floods and droughts? But it didn't take Ibn al-Haytham long to realize that the Nile was way too large to control. On hearing this, the Caliph flew into a terrible rage and ordered Ibn al-Haytham's execution. Ibn al-Haytham responded by feigning madness. The execution was called off and he was placed under house arrest. There, with time on his hands to contemplate, the story goes, Ibn al-Haytham considered deep and fundamental questions in physics. And he began with a truly enigmatic and universal problem. He asked if the wonderful and entirely mysterious nature of light and vision could be explained by mathematics and geometry. Under house arrest, or perhaps here in the rooms of Al-Azhar University in Cairo, Ibn al-Haytham carried out a series of experiments that created the modern science of optics. I'm with Dr. Al-Bizri, who has carefully studied Ibn al-Haytham's work. He explained that Ibn al-Haytham first considered the Aristotelian explanation for how we see, an explanation that was completely unmathematical. Aristotle argued that when we look at, say, a tree, its essence or form emanates from it and then mysteriously flows into our eyes.
So if I'm, for instance, now looking at the buildings and the trees on the banks of the Nile, I'm receiving the forms of these buildings and these trees in the eye, abstracted from their matter.
According to Dr. Al-Bizri, Ibn al-Haytham found this idea deeply unsatisfactory. He wanted a mathematical explanation. And looking back at existing Greek writings, he found one, although it was obscure and bizarre. This idea claimed that we see because light rays come out of the eye.
Ultimately, it says that vision occurs by way of the emission from the eye of light that is shaped in the form of a pyramid or a cone.